All right, everyone. So today we are going to talk about inverse functions. In order to do that, we're going to discuss things. We're going to think about socks and shoes. And to do it, I'm going to show you a quick little video here. Look at this.
When you put it, be careful. You have to make sure the whole of your feet is covered. Make like that. And then make like this. If you have something like stones and things like that, look at this big stone.
And you put it on the floor?
Yeah.
Okay, great.
For a while. Then was I precisely correct? Oh, then you make like this.
And ask yourself, what does socks and shoes have to do with inverse functions? Well, my initial functions I have to put my socks on first, followed by the shoes. In all practical purpose, I cannot do it the other way around. That's the initial function. The inverse function, I have to take the shoes off first, and then the socks come off. It has to go in that order. And so the inverse operation of putting your socks and shoes on is shoes and then socks. And so what the inverse is, it's inverse operations in reverse order. Another example that I love, imagine you're typing away on your computer and you turn, as you hit, you magically, all the screen deletes. You freak out. What do? The first thing you do is you hit Command Z. You hit Command Z on your Apple computer and all the things come back. You can even go back several things, and it does the inverse operation in the reverse order. You can get many things back. This is what mathematics, this is the computer version of this mathematical idea of inverse. And so let's look at some equations here now. Let's consider f of x equal to this scenario here. Okay, I want to take a look at this function, x plus 2 square rooted plus 1. Is this equation a function? Well, the easiest way I can think about it is I want to start off with my square root function. And my square root function looks like this, and it starts here. The effect of the plus 2 means I'm going to shift it this way too. The effect of the plus 1 means I'm going to go up by 1. So my graph is going to go over 2, 1, 2, and up 1. Here is my new function. If I look at that function there, use my vertical line test, I think, does it ever touch the graph only one time? And the answer is yes. So is it a function? You betcha. It is a function. Yes, it is a function. Here's my sketch. The domain now, well, if I want to do the domain, I think about all the x values. And it starts here at -2, x is bigger than or equal to -2. And the range is all the y values going up, horizontal lines up here, and that is y is bigger than or equal to 1. Okay, there's just a quick review. Now, to calculate the inverse. And what I just said is that it's the inverse operation in reverse order. So, if I think about this function here, my initial function is the square root of x plus 2 plus 1. Imagine the first thing I do to this function. So in doing this, if I have an x value, if I think about order operations, the very first thing I do to x is I will add 2 to it. Once I've added 2, then I will square root the value. Once it's been square rooted, then I will add 1 to it. And this is the direction of f of x. If I want to do the inverse operation, the inverse of adding 1 is subtracting 1. The inverse of square rooting, well, that's taking something and raising it to the power 2. The inverse of adding 2 is subtracting 2. And so to find the inverse function, I start with my x and I go in this direction. First thing I do is I subtract 1, and then to this whole equation, I square it, and then I subtract 2. And this is the inverse function of f. Let's consider the graphs here. Okay, I have our function. This is the one that we were given. And I'm going to add onto it the inverse. There is the inverse of it, the orange one or yellow one. And you'll see that it only has part of it, because if I look at this, I only want part of the graph to show. And as I change different a's and b's, you'll see, hopefully you'll notice something. What do you notice about the blue curves and the yellow curves as they change different values? Hopefully you recognize that you get a reflection of each other. And so the inverse is just a reflection over this line, and this line is y equals x. And so if I want to sketch the graph of this, I know that it's a quadratic, but it's not all the values. It's only going to be half of them. And it is reflection over the line y equals x. And so to reflect it over the line y equals x, what do you notice happened to these coordinate points? This is negative 1.3, and here it is. If you'll notice, the x values and the y values switch. So if I'm going to do it here, if I'm going to sketch this graph, I'm going to take these x and y values and I'm going to switch them. This point I know is negative 2, comma, positive 1. And so that will become positive 1, comma, negative 2. So positive 1, negative 2. This point, if I estimate, is 0, comma, 2.5. So I'm going to go 2.5, comma, 0. This is 3, 3, so switch 3 and 3, I get that. And so my inverse function is here. It does not keep going, and I only have this part here. So when I sketch it, the domain of this is just going to be x is bigger than or equal to 1, and the range is y is bigger than or equal to negative 2. What I want to recognize is we just figured out that the domain of the inverse I just said was x was bigger than or equal to 1, and the range was y was bigger than or equal to negative 2. And if you notice, I switch my x's and y's for the inverse, my domains and my ranges switch as well. So if you know the range of one, you know the domain of the other. Okay, so going back to my usual thing, I also know that inverse is a reflection over the line y equals x, and it is a switch the x and y values. And the function, the inverse, if f of x is a function, f to the minus 1 of x is the notation for the inverse. We'll get to that later. Okay, so we've looked at different ways of looking at the inverse. Let's now calculate the inverse one more way. And the other way I can do it is I can switch my x and my y around. I know this function here is y is equal to the square root of x plus 2 plus 1. So if I switch my x and y, it's x is equal to the square root of y plus 2 plus 1. And then I solve for y. I do that by subtracting 1 from both sides. And then I raise it to the power of 2 to get rid of my square root sign. Those cancel. And so y plus 2 is equal to x minus 1 squared. I subtract my 2. And so then I can say x minus 1 squared minus 2 is equal to y. and I answer it with good notation at the end. So the inverse of f is x minus 1 squared minus 2. So that's another way of doing it. And if we look at our previous way, our previous method, we ended up with the same equation. So to summarize this, there are 4 different ways you can think about the inverse. It's the inverse operation in reverse order. It's Command Z, which means you are undoing what was done in the inverse operation in reverse order. So if I start with something and I do calculations to it, and then I undo it, I end up with the same thing. So if I do my inverse of my function, I end up with x. I start with what I end with what I started with when I do both functions. I can also look at it as a reflection of the y equals x, or a switching of the x and y values. All right, let's try another example here. This one's a little bit trickier to do the inverse. So here I'm going to calculate g at 1. That's fairly straightforward. G at 1 is equal to 1 minus 3 over 1, which is negative 2 over 1, which is negative 2. Easy enough. So now I'm going to add a part C, which I'll do first. I'm going to go, what's the inverse at negative 2? Well, the inverse of negative 2 means this is the y value of this. And so the answer will be 1. It says switch your x and y. That would be C part. B now, find the inverse here. Well, if I remember, I take my x and my y and I switch them around. So I get y is equal to x minus 3 over x. So switch my x and y, I get x is equal to y minus 3 over y. And so now I have to do some algebra on here. I got 2 y's, I need 1 y. I'm going to multiply both sides by y. That will cancel this, which leaves me with xy is equal to y minus 3. Now I have no fractions, but I have a y on the left and the right. So I'm going to put them both the same side by subtracting y equals negative 3. And now if I look here, here's the hard part, I think. You have to recognize that there's a common factor of y. It leaves an x minus 1, which equals negative 3. And so y divided by x minus 1 is this. And so I can say the inverse of g is minus 3 over x minus 1. And finally, our last example. Here's a function here. I want to make the inverse. Well, to do it, I'm going to switch all my coordinate points. I know this is 6, 5, so I'm going to go 5, 6. This is 2, 4, so I'm going to go 4, 2. This is 1, 0, switches. It will switch, and it will switch. And so my inverse function, as I switch my x's and y's, I use the idea of switching x's and y's to reflect it over y equals x. There is your theory on inverse functions.